A local repair shop said that they couldn't fix this laptop because of this battery connector having been torn off the motherboard. Let's see if we can fix it. I am fortunate enough to have two of these laptops. One that has a bad motherboard and one that has a good motherboard. So I'll be able to jump connections on the bad board with the good battery connector to test where I can solder parts to. So I'll walk you through the process for how I'm going to do this as well. The connector on the battery has three different colors of cables: red, white, yellow, and black. The connector on the motherboard has the same amount of pins. 3 that would allocate to red, 1 that would allocate to white, 1 for yellow, and 3 for black. So what I can do is test those connections. And again, this is the motherboard that is bad, but the battery connector is good. So what I'll do is I'll take my multimeter, put it in continuity mode, so that when I connect 2 ends of a circuit, it closes and makes a sound. And that'll let me know that the 2 connectors I'm probing are closed on a circuit, which then means I can use whatever those pins are to solder my connections to on the board with the broken battery connector. So I'll start with the negative side. So these 3 here are the ones that correspond to the negative, the black wires from the battery. And I've already done the probing. I already know that I can complete a full circuit, but I'm going to just demonstrate it here for someone else that might want to replicate this. I don't recommend this. This is not professional advice. This is just what I'm doing to fix my own device. And maybe it'll inspire you to do something on your own too. So I touch one end to the post that the battery connector mounts to, and then I connect the other end to any of the 3 terminals that would correspond to the negative cable, the black cable right here. I can do the same thing for the positive end, but you'll notice that this connector here doesn't ground out to the mounting post on any of these 3 connectors. It's only the negative side that completes a circuit to both of these. Well, there you go. Right there, it's another circuit. But I found it's a little strip of metal right there that completes a circuit with the positive terminals. So that is what I'll be prodding when I touch the positive posts. So that metal strip is what will complete a circuit to each of the 3 positive connectors for the battery. And now it only raises 2 more connectors that we don't have a complete circuit for: the white and the yellow. Finding these connectors was a little bit trickier, but I did find spots where they terminated on the back side of the motherboard. Yes, I said backside. Stop laughing. The 4th one from the left, so the one that would be right next to the positive cables here, is the white cable. The white cable closes a circuit with this pin on the back of the motherboard. The yellow one, which is the 4th one from the right, closes a circuit with this terminal. Quick recap before we actually start soldering anything. These 3 connectors, red, positive, they terminate that strip of metal on the board there. Second, the 4th connector, the white cable, connects to this pin on the back of the motherboard. Thirdly, the 5th connector, the yellow cable, completes a circuit with this pin on the back of the motherboard. And last, 3 black wires, those terminate to either the mounting point on either side of the battery connector. So that's what I'll be soldering to on the good board here. So my goal was to take this old RCA connector, snip the wire, grab the metal pieces out of the wire to route to the back of the motherboard. So my whole philosophy was take the terminal, since the post is completely ripped off the motherboard, route a cable underneath to the 2 posts that the white and yellow cables need to go to. And again, white on the top, yellow on the bottom, closest to that little nub there. The best way I was able to get that to work was to take the wire that I had twisted together, trap it underneath the hard drive, butt this connector up to it, and then solder it. I'll do the same thing on camera if anybody wants to follow. And now, it looks a little something like this. 2 wires connected to the white and yellow connectors on the battery connector. I now have 2 more wires to solder onto the positive and negative connectors. So for my next magic trick, See, that should work all right. Okay, cool. And then we'll just do the same thing for the other side. There we go. So now that we have all the wires soldered to the battery connector, the last thing I want to do is just double check and make sure that there are no connections that were jumped. And it looks like in this case, everything appears to be just fine. These three, those two, those three. And now that we have that done, we can finally get started with soldering this connector back to the logic board. So I am going to take probably the positive one here and do that one first. I'm thinking that'll be the easiest. Pin this side down. So now, to test that connection, I can take my multimeter, continuity mode, set it so it'll beep, and then I can touch this wire to this contact. It should beep on all three of those cables and nothing else. Perfect. There we go. So now that one's connected. Now we need to do the negative one, which is going to be mounted to the terminal post over here. Learning from the last one, I found out that those posts needed a little more solder on them. So let's put a little more on that connector mounting post there. Careful not to hit the NVMe slot, or the M.2 slot. You can see the entire connector wiggling here because it's not glued down anywhere. Nothing's connected to the board. Now that we've got those two connectors on, the one soldered to the post down there and the one up there, we should be set to move on to these cables that have to run to the back now. These are going to be the tricky ones because I have to dodge all of these connectors down here. Now, because these cables are not shielded in any way, shape, or form, what I'm going to do is just lay down a little strip of electrical tape to make sure they don't short out any of these other little connectors on the board. Cut it down in size so that just those two terminals are exposed, and I will have plenty of room to route the cables as needed. Just to give a better view, I've essentially just isolated the two pins I'll be soldering to. First, I'm going to add a tiny bit of solder to the post. And then there we go. Those are connected. And what I'll do is with any excess cable after the solder point, I will wiggle it back and forth until it snaps off. But that looks about good. Those two joints. That's what it looks like. So now, the big question, did I do it right? So I'm going to have to put this back in a laptop, connect a battery, and see if it blows up. Well, the laptop is fully reassembled, or the laptop is partially reassembled, at least to the point where I can connect a battery and give it a test. The super glue still has a little bit of drying to do, but my goal is to just connect the battery, give it a power on, see what happens. So I have not tested this yet, so this recording will be my first time powering it on. Let's take the battery screws out. We won't toss an SSD in because we don't need it to boot to an operating system. We just need to see if the connections to the battery are good enough for it to boot on its own power, as well as hold a charge. And I have already tested the laptop previously, so if it doesn't turn on, then that means I really screwed something up. Now, the one major flaw with this is this little piece that's supposed to connect or hold the battery in the connector can't fit on with the cables stuck in place here. It's entirely possible the battery might just disconnect on its own, or that the plastics just aren't aligned properly. Here goes. Press connector is connected. So now let's grab a charger and let's see if she'll turn on. Battery charge light. We have a light indicating power and one indicating that the battery is charging. Now, let's see. Okay, still power's on. Shows 16 gigs of RAM, Core i7 10th gen. Let it charge for a little bit. It works. And now the only test left to do is see if this laptop reads a battery percentage with Windows. So I've taken a WD 1TB SSD, SATA SSD, out of another laptop I had, and I'm going to toss it in this one. I've charged the battery for about 20 minutes, so this should give ample opportunity for the laptop to fire up, boot to Windows, perform any testing it has to do. There we go. So we are finally in, and it is showing a battery charge, 61%. It's running on battery. Just fine, no issues, no problems, no concerns. Obviously, I'll have to do an extended battery test to see exactly how long this will last on a charge, but I see this as an absolute win. Now, obviously, this video is on my business's channel, but the message I want to portray is this. Never let someone telling you that they can't do it be a reason to stop you from learning it and doing it yourself. If you need a repair, my contact info will be below. Feel free to reach out if you have any other questions regardless. Happy holidays.